Make sure you hold on to this sheet and you keep up with your warm-ups, okay? All right, so this is our first warm-up for the 2 weeks. The next thing that we're doing today is going to be notes. So you can, if you would prefer, can you guys see me, or is it still not connected to me? Can you guys see me at all?
Yeah.
Okay, perfect. So these notes are what we're doing today. You can print them out. They are connected or linked in on our activity 1. If you don't have a printer, that's totally fine. Just follow along as I write on these. I'll try to go pretty slow so that you can keep up. And please tell me if I'm going too fast, okay? So we're going to take some notes, so get ready to do that. About half of you have your cameras on and half of you don't, so I need cameras to be flipped back on. All right, so I'm going to open up my document camera and share my screen again. Okay, so can you guys see our, oh, my IB class really needed it, zoomed all the way in today, so. Let's see, we're starting on this side. I was right. Okay. You guys see the document? We're good? You know what? There's one more thing I want to pull up. So for this activity, there is a PowerPoint that goes along with it. And I'm going to pull that up so that you can follow along. You can pull it up on your own computer if you would like, but I'll pull it up for everybody just in case. So give that a minute and it should pop up. Okay, so first, so we're talking about functions today. Our very first unit for Math 3 is functions. So we're going to start there. So we're going to first define function. A function is a mathematical rule that for each input or x value, there is one and only one output, or y value. You may have seen a function described like a machine where you put something in and the machine is trained to output a specific thing. Okay, so we put in our inputs and maybe our rule, the thing that our machine is trained to do is to square our inputs. So it's going to take whatever we put in and it's going to square it, and then it's going to have a specific output. Okay, and when we put individual inputs in, there can only be one unique output. Okay, we also describe it as a rule. So the rule for this would be x squared. We're taking all of the x's and we're squaring them. What questions do you guys have so far?
Miss Roberts?
Yes.
Whenever you finish the paper, are you gonna like take a picture of it to post in case?
Absolutely.
Because it's kind of hard to see. It's like glitching and stuff.
Oh, I'm sorry. It's not glitching on my side. Yes, I absolutely will. That is no problem at all. Let me try to move this so that maybe you can see both the PowerPoint and the sheet a little better. But I absolutely will do that. Okay. Questions on the material so far, or any other issues, tech issues? Okay, so our domain are our inputs or x values. And we talked a little bit about this last week. Let me get this so that it'll move through. Oh, it did. Okay, so a function is a mathematical rule that for each input, we have one and only one output. Our domain are our input or our x values, and our range are our outputs or y values. Okay, questions so far? So this one and only one output rule essentially means if I have a function and I stick in 2, okay, if I stick it in twice, no matter what, I should get the same output. If I get 4 one time I stick it in and -4 the next time I stick it in, that does not work, okay, because we have 2 different outputs. That relationship would not be a function, okay, so that's what it means by one and only one. Okay, so the next thing we're going to talk about is when we can tell it's a function. So there are 3 different representations that we're specifically going to look at. We're going to look at the graph, ordered pairs or tables, and then a map. Okay, and we're going to tell whether or not it's a function through each of those representations. So on a graph, to tell it's a function, it has to pass the vertical line test. Okay, so the vertical line test is the important thing there. To do the vertical line test, you put your pen up and down the function, and it should only touch the graph one time. If it touches it more than one time, then it is not a function. So for example, I could have my absolute value function. And to do my vertical line test, I should be able to draw a vertical line, vertical means up and down, anywhere on my function, and I only pass through one time. So I can draw my line anywhere on this function, and it only passes through one time. Okay, what questions do you have so far? Do you guys need a minute to write things down?
Yes.
Okay, thank you.
Could you zoom in on it a little bit?
Absolutely, thank you for asking. Okay, and I'm still seeing some screens without cameras on. You guys need to have your cameras on, please. All right. The next one is ordered pairs or tables. And all you look for in this example is that no X values repeat. Okay, so if we go over to our PowerPoint and look over here, we have a bunch of ordered pairs here. And all we would do is we'd look at each of the X values, 2, 4, 7, -1, 0. All of those are totally different, so that's a function. We have a table here. If we run down the X values of this table, every single one is totally different. So we see that this is a function. Here's another set of ordered pairs. We have apple, blueberry, banana, and cherry as the X values for those ordered pairs. All of those things are totally different. Okay, so no X values repeated. So I'm going to do my own example here. Maybe we have a table. And our X values are -1, 0, and 1, and my Y values are -1, 0, and 1. So like we have X and Y values that are the same, but if we just look at the X's, every single X is different, okay? So because every single X in that column is different, we have a function because we have no X values repeated. Questions on that? Okay. Do you guys need a minute to write that down, or can I move on to the next box? Okay. So now the last one is talking about the map. A map is referring to, maybe we have X values here, Y values in this bubble, and we have numbers in those little bubbles. And then we have arrows that show which X value maps to which Y value. Okay, so in this case, we know it's a function when no X value has more than one arrow coming from it. Okay, so in this example, we have exactly one arrow for every X value. It's okay that both of these arrows point at the same Y value. That is possible. But each X value has an individual arrow. So those are all examples of how functions work. And now we're going to move on to non-examples of a function. Okay, so for non-examples, we could have a circle plotted out on our coordinate plane. This is not a function because when I do my vertical line test, I pass through 2 times. Okay, so passing through 2 times on the vertical line test means it fails. Vertical line test. Okay, and it is not a function. You also could have, maybe you flipped your parabola sideways. The vertical line test gives us 2 points, so it also fails the vertical line test. Okay. Another example that I like to give, maybe I have a vertical line, a line that goes up and down. Maybe this is the line x equals -3. If I draw a vertical line using my vertical line test, I can get infinitely many points on here. So this also fails the vertical line test. So a vertical line is not a function. Questions on those 3 examples? Okay, and the very last one is our map. Okay, for a map, I'm going to put 1, 2, 3, 4, 5, and 6 down. I'm going to have 1 map to 4, 2 to 5, 3 to 5, and 3 to 6. Can somebody tell me why this one is not a function? These are my x's and these are my y's.
Because 3 has 2 arrows coming from it.
Exactly. 3 has 2 arrows coming from it right there. Okay. So that's the issue. All right. Thank you very much. Okay. So, and you can see in the PowerPoint, it has the circle, the sideways parabola. It has the vertical line test definition again. We have some ordered pairs here. There's 1, 1, 1, 2 are my x values, so that definitely fails.